aside.
Sorry.
Is this
Became a little
bucket?
rant.
This bucket?
Yes.
I've never spotted that before.
Oh, there's a bucket on that roof. Yes,
There's
of
a
course.
bucket on the roof. Oh, I
Oh,
zoomed in too much.
there we go. In
Yeah.
fact, you could probably go to the images and you could open an image that shows you that bucket.
How did that bucket get there? That's what I want to know.
That
That we obviously can't fathom out. Let's make that smaller.
Yeah, that's a very good question.
There's
There
the
you go.
bucket.
There's a bucket. You can zoom in and all is glory. And
There you go. The infamous. Good afternoon.
good afternoon, Alex. How you doing?
Yeah, I'm good. I'm good. I've had my heating on in here all day,
Nice.
and now it's a bit warm,
Oh,
bit
nice.
sweaty, bit
Mm.
sweaty.
Mm.
So we've been working on this one.
We have, yes.
Yeah. So what's it called, Varun? Go on, you
No,
do the
you,
intro.
no,
Or
you've
me.
got you've named it, so you've got to you've
It's
got to introduce
called. So this week's podcast
Mhm.
is called Dodgy Datasets.
Dodgy Datasets.
And just a quick one before we start.
Mhm.
It's quite a visual one, this one.
Mhm.
So, I mean, anybody listening, apologies that you're not going to be able to see what we're, our antics and what we're getting up to. But by all means, it will be recorded for YouTube as well. So you can go to Hammer Mission's YouTube page and check out podcasts, because obviously we record all of them visually, as well as with audio. So you can check out what we're up to on there. But hey, I mean, stick with us. You might have a laugh. You can have a listen.
Yeah. And we'll try and describe everything we're seeing.
Yeah.
So that,
We'll try that as well. I mean, obviously,
Yeah.
visually, it'd be a lot better to see it.
Yeah.
Like you can't see my ears because they keep disappearing.
Ears are overrated.
Ears are overrated. Yeah. Yeah. Get rid of ears.
It's funny. Funny thing to say on a podcast.
Who needs them anyway? So yeah, I guess we'll just kind of hop on with it. We've had, I mean, this is podcast number
17, I think.
17 weeks of podcasting.
There we go.
It's good fun.
Mm-hmm.
Good fun. I feel naked. I'm not wearing my Hammer Missions jacket.
That's all right. You're not naked. For those listening, he's not naked.
I'm not. I've got a jumper on.
Yeah,
I've got clothes on. I'm not naked.
Yeah.
I don't podcast naked.
Yeah.
Not on this podcast anyway.
No.
Cool. Let's crack on with it then.
Let's crack on. So what are we doing? So so it's called Dodgy Datasets, but do you want to explain why it's called Dodgy
Okay,
Datasets?
so we've been out and experimented with 3D mapping.
Mm-hmm.
We're using the good old Mill, which I guess a lot of listeners, maybe viewers, won't have seen. So today you get to see the Mill.
Oh yeah, true.
You get to see it in its glory.
Wow.
Not that it's particularly glorious, but it's there. So the idea today is to compare 3 different data sets, all taken of the Mill, and compare the data between those 3 data sets and the pros and cons of each data set.
Mm-hmm.
I think the first data set being obviously the first one we did, right up to the last data set, which was the last one we did. And we will go back when the weather's cheered up here in the UK. We will go back and do some more, and we'll just continue. We'll continue putting these data sets together to build a better picture of the Mill and of what we're trying to achieve.
Yeah, absolutely.
So with no further ado, go on. You got something to say?
And just to add to that, I think one of the things we want to do in this particular episode, which is building on top of what Alex just said, is we want to try and contrast we want to critique some of the data sets and sort of say what's good about them and what's bad about them, so that we can sort of say what's a high quality data set and what's not a high quality data set, and how can we make our data sets more high quality, because ultimately, as we know, in the drone industry, it's all about the data. And if it's all about the data, then high quality data is what adds the most amounts of value to the end customer. So hopefully this exercise helps us have a healthy kind of discussion about, what are the things to look out for to make your data sets better.
And these are our data sets, something we've gone and collected. And there's always room for improvement. And as I've said, when the good old British weather cheers up, we will go back out and we'll reshoot and process again, and then reshoot and process again until we have something that is substantially better than Dataset One, all the way through to however many data sets it takes. So I will share my screen because I have all of those data sets live at the moment. So bear with me a second, folks. Boom.
Boom. There we go.
There it is. So here be dataset number one.
Dataset number one. So what do we see on the screen? So we see a capture of the mill.
Yeah, it's a project. And as our regular users of Hammer missions will know, you go out, you collect data in the field, you put that data into the Hammer hub and you process it as a project, and then you can process it as a 3D map. So that's what we have here. We've got a map, a 3D map of the mill. There she is, or parts of her anyway. So we can zoom in there. That's the mill in all its glory. So this
is definitely the first data set, as you've correctly identified.
This is Dataset One.
So as people can see, there are two different captures or two different flight paths that have been executed and then uploaded to Hammer Hub in this particular data set. So for the people listening, basically there is a top-down nadir data set forming a rectangle on top of a L-shaped building. And then there is also another data set which is forming a facade, a rectangular facade in front of the facade of the same building. And the two data sets are completely disconnected from each other. So the two image groups of images are completely disconnected. And one of them is representing the roof of the building, and the other one is representing the facade of the building. So that's what we gave the computer as input, or Hammer Hub as input, and then we let it process all of those images into one 3D model.
So you can see all the images below down here. And this is the 3D model it has created. So for those of you that know 3D or don't know 3D, some of it's actually pretty good. The detail, obviously, with the Hammer Hub, it does load. The closer you get to it, the more detail it will pick up. Some of it has turned out pretty well. I would call that a pro. It's even picked up some of the undergrowth that seems to be growing up the side of the mill because it's derelict and nobody loves it apart from us here at Hammer.
You could even try, if you maximize it, it might be easier for people to see you on a smaller screen as well. Like you'll see that.
There we go.
That's
better. Thank you, Varun. I didn't even think about that.
No worries.
So there's the mill. But as you can see from the facade end, the data is terrible.
The
facade hasn't rendered at all. And the same with this facade here. This one and these have rendered pretty well. So I guess some of the pros of that are we've got some good overlap from the nadir position.
So within the set of images representing the nadir, there's good overlap. We have, it's gone slightly skitsy on me. Bear with me a sec. That's my mouse rather than anything else. What we have done here, obviously we've covered the whole object. So it's picked up the trees, it's picked up, this is actually a water feature. It's not, it's like a
plot of water. It used to be a mill.
Yeah.
And it's picked up some of the back area here. So we didn't follow the shape of the structure.
Yeah.
We blanket mapped it basically. When we want to map that, we'll just map the whole thing.
Yeah. Exactly. So yeah, sorry, go on.
So obviously there's no overlap between the two image groups because we've got a massive gap between the two.
Yeah.
There's no representation between these. And we're not following the geometry of the building. Although we've overlapped the facades of the building, we've also taken into account all of this foliage and trees, etc. down here, which, let's face it, we don't really need.
Yeah, it's extra images.
It is. It's extra images, it's extra processing time, and it's extra processing power. So for all intents and purposes, Project One, we call it, Dataset One, is okay.
Yeah.
It's it's not great, but there are certain aspects of it that have come out very, very well.
Yes.
I mean, if you just wanted to survey the roof, for example, that is more than adequate.
Yeah. So you're right.
Yeah.
So I think from a roof survey point of view, this is a good data set. But if you wanted to model the entire building, then as you mentioned, the facade has not come out really well. And the main two issues that we see with this data set is that there is no overlap between the nadir and the overlap images. So as in the two image groups are completely disconnected, which Alex is very nicely indicating at the moment with the mouse.
Like a magician's magician's helper. Here they are. Here they are. Yeah.
And the other thing that Alex already mentioned is that the images, even on the roof, are not following the geometry of the roof itself, and there is an excessive capture images that you don't need, which are taking up unnecessary resources and not really contributing to the entire building modeling project. So that pretty much summarizes data set number one.
Yeah, that's data set number one. So we'll shrink that one down. And we'll move to data set number two.
Data set number two. So what did we do different for this one?
So what we did here is we went back to the drawing board and we thought, right, how can we vastly improve what we'd already done? We need to capture the obliques. So we need to capture the obliques of the building to build our 3D structure. So we originally tried a facade and it didn't work. For whatever reason, it didn't work. So we thought, okay, well, I think we ran a tower mission on this one for obliques. So we set up the standard 3D data mapping over the nadir, and to capture the obliques, we used the tower mapping mission. And obviously, what the tower mapping mission does is it runs an orbital around the building. Then we manually set the camera. I think it was about, I can't remember the degrees, but it was obviously pointing down towards looking at the building.
Roughly 45.
It was roughly 45-degree angle. So this is what we ended up with. Look at that, by magic.
By magic.
By magic. So it's a lot better. I mean, already we've got facades that we didn't have before. So we've got a facade on the front of the building. Running all the way around, we have I won't go to the back yet. The top, the nadir, still very good. It does take its time to render. Just the nadir is very good. And again, some of the closer facades have actually come out.
Yeah.
But you will notice on the back side of it, we have a horrible kind of Dali-esque facade.
Yes, there we go.
Yeah, it's like a Picasso painting. It's horrendous.
Yes.
So we'll go into why. Let's talk about the pros first.
Okay.
So this time round, as you can see, if we zoom right out, we followed the geometry of the building.
Yes.
The building's an L shape, so we did that.
Yeah.
We did an L shape,
Mhm.
which I think has certainly upped the ante and
Mhm.
given us more bang for our buck.
Mhm.
So the data quality is a lot better,
Mhm.
following the sort of the shape or the geometry of the structure.
Mhm.
And within the image groups, so within our nadir,
Mhm.
the overlap's good.
Mhm.
We've got good coverage.
Mhm.
And within so within a percentage of the obliques, the overlap's good.
Mm.
So we're not quite sure. Actually, did we write? I don't think we did this with. No, we didn't do this with a tower mission. I fibbed. We did this with we did this with a customized facade mission.
Right, that's correct. Yeah. Mhm.
Yeah, so I take back the tower mission. I think we had done one previously with the tower mission,
Mhm.
which we're not showing you here.
Mhm.
This was with a custom facade mission.
Yeah. Mhm.
And what has happened is the back end of the building,
Mhm.
it hasn't stopped and captured.
Mhm.
It's basically flown a straight run down the back of the building and captured on the move. Hence
Yeah.
the reason the back of our building does indeed
Yeah.
look like a kid's drawn it.
Yes. there is that. So the oblique, there are quite a few missing oblique images,
Yep.
which makes this data set dodgy. And then the other thing that is missing also is that if you look at the last row of the nadir images, so in that L shape of nadir images, the last line or row of images that Alex is pointing out, they do not actually capture the facade in any way. The images are straight down and they capture just up until the edge of the building, as opposed to any of the facade. So I think from a coverage point of view, as you mentioned, Alex, one of the things that this dataset could benefit from is an L shape, but a bigger L shape with some margin, so that the nadir images can actually capture some of that detail in the facade. And then also the oblique images, if there was good overlap between them in the image group of the oblique images, and also more overlap between the nadir and the facade, between the nadir
Customized
and
facade.
customized facade. So basically between the oblique images and the nadir images, the two image groups should also overlap. So if this is in my hand, if this is the, well, I'm showing a hand basically for the people listening. I have to say, people listening have to watch this. And there is a second set of images on the side representing the oblique. These two need to have a good overlap between them. And the reason for all of this is because the way photogrammetry works is that for photogrammetry, the software needs to be able to estimate the position of different pixels in 3D space. And the way it does that is by isolating specific features in the structure building object. And if there are images that don't align or don't agree where the 3D point is, then it's hard for the software to know which image to trust, because they're disagreeing fundamentally. But if there is an overlapping part, it allows all the images to agree roughly. This is the most high level way I can explain it.
You can actually see from here the front of the building. So here we've got plenty of overlap that sits over the top of the facade. So you can see the facade. It makes, it's made up of these images here from the nadir above the facade, and these images on the oblique, albeit, not overlapping.
Yeah.
Whereas on the back end, on the back of the building, there is no overlap for the facade. So it's only got the oblique images to work on.
Yeah.
And those oblique images ran far too quick. Hence the reason they're blurred.
Yeah.
So there you go. That's Dataset Two.
There we go.
Numero dos. It's the only bit of Spanish I know.
For the Spanish
Right.
listeners.
Yeah, for the Spanish listeners, numero dos, number two.
Right.
So number three.
Right. Number three.
Aha.
Mm-hmm.
So you can already see. Let's just make it bigger. Bing. There we go. From our Nadir,
Mm-hmm.
we have
Yeah.
lots of overlap
Yeah.
on the back end.
We've increased the margin. So
Increase the margins, overlap on the front end, overlap on the facade. In fact, on this one, we have added at a later date a facade mission.
Yeah.
This was another project we were doing.
Yeah. So that can be ignored because it wasn't actually processed. So
yes, this wasn't part and parcel of it.
Mm-hmm.
So the pros here are plenty of overlap.
Yes, plenty of overlap between the nadir as well as the oblique images. And then the images following the geometry of the building, which is the L shape with a healthy margin. And basically just higher overlap within an image group and also across different image groups.
This was also done with a custom facade mission.
Mm-hmm. Yes. So
you can see the quality is a lot better.
Yes. And if you go to the back, you might be able to showcase that the back of the building has been reconstructed.
Yeah, much better. We are missing a few parts of it.
Yes. And
I think this was probably to do with some overlap issue.
Well, to capture underneath roofs or to capture some of those parts of the building, this is where this data set falls short, is because it only did one row of the facade capture.
That's right.
If you wanted to have a really high quality model of all parts of the building, then we would have to repeat the facade alongside on many altitudes. The oblique capture would have to be on multiple altitudes along the building.
Yeah.
So there is basically...
it's also shown here, isn't it? Where you've got this lip that sits out over the top, which is, I think it was a gantry. Underneath, obviously it can't see that, so it hasn't rendered it.
Yeah.
But you're right. To gain quality, you would need multiple facade runs. So this was just done with one single run. Yeah. You'd want to run, once around the top, then come down, get as many runs in on the facade as you possibly could, obviously safely.
Yeah. Yeah. As a general rule, if the images do not showcase a part of the structure or the building, like none of the images do, then it's going to be very hard for the software to recreate it because it's only recreating what has been captured. It can't produce new stuff from thin air.
No, it's not that clever yet.
Yeah. So not yet is a good point. And it needs that overlap between all images, between all different types of image groups, for it to be able to put different things in the right place. And it needs to follow the geometry of the building or structure you're trying to capture so that it can be easier for it to understand what the 3D of it looks like. So I think there's three main overarching principles here. From the principles is a good way because principles apply across different data sets. So if people are principled about the way they're collecting high quality data, then they can get good results no matter what building or structure they're trying to reconstruct.
But all in all, I think what we've achieved from Dataset One to Dataset Three is a vast improvement, but there's always room for further improvement. So obviously, as I said earlier, when the weather picks up, when things are looking a bit brighter here in the UK, we'll go back and we'll carry on our experiment with the mill before they tear her down.
Yeah,
I'm not sure when they're doing that or if they're even doing it. It's a listed building, and we'll continue to create data sets of the mill until we've created one that we can not do anything else with, basically.
Yeah, absolutely. And the thing is that this is another interesting every project is different, every building is different, every structure is different. And over here, one of the things that was challenging, as I recall, is that we've got some dense vegetation, trees growing right in front of the facade.
Yeah.
And so sometimes it can be really hard to actually get an automated drone in there.
Here.
Exactly. So sometimes you might have to mix manual capture with automated capture to get the best results. Sometimes you might have to consider mixing drone images with other images just because access is limited for a drone. No two projects are the same.
No.
But I think as long as the quality of the input data set is good and high, then you can expect high quality results no matter what software you use. The challenge is that a lot of the times people don't analyze the actual workflow of capture and hope that they would get great results, which we're obviously trying to kind of change because we want people to know and have the information. What is a good high quality data set? What are the things to look for? What are the things to watch out for? And then whatever software you choose is up to you, and up to what you feel most comfortable with, or most that you think you get the most value out of. But I think the workflow and processes, those things the principles of capture can be with you no matter what tool you use.
What interests me, Varun, all that aside,
sorry,
is this
bucket.
Rant. This bucket.
Yes.
I've never spotted that before.
There's a bucket on that roof. Yes.
There's a bucket on the roof. Oh, I zoomed in too much.
There we go. In fact, you could probably go to the images and you could open an image that shows you that bucket.
How did that bucket get there? That's what I want to know. That we obviously can't fathom out. Let's make that smaller.
Yeah, that's a very good question.
There's the bucket.
There's a bucket. You can zoom in and all is glory. And
there you go. The infamous bucket. It'd be interesting to see, with all the high winds and stuff we've had over winter, when we go back when the weather's sorted itself out, if Mr. Bucket has moved.
Yeah. Maybe you want to annotate that bucket and leave it in there, and then when we do the next capture, we can compare. I'm gonna annotate the bucket. There we go. The bucket.
Make it serious.
Serious issue.
Comment.
Bucket. The bucket.
There
we go.
She's there for future use. The bucket.
She's sitting there.
And anyone wondering about annotations, we haven't done a podcast on that yet, have we?
Probably not. We? No,
I don't think we have. So that's something we'll pick up on at a later date. But yes, you can annotate these 3D models. But this is the first kind of extra visual podcast we've ever done.
We have, yeah.
So I hope everyone likes it. It's a bit of an experiment for us.
Yes.
But it's something we wanted to kind of explain and show people, that collecting high quality data is important.
Yes.
Yeah. And we're always experimenting and upping our game to make our software a better product.
Yeah. And if not anything else, I think what's important to us is that
I'm going to stop sharing now.
Yeah, you can stop sharing. Thanks, Alex. That's great. I think what's really important for us is, for this information to be out there, and it's not something that I think there's a lot of people that want to keep their workflows cagey and kind of like, secretive or whatever. Like for us, this information should just be very readily, easily available for anyone to just learn. And people shouldn't have to pay like courses in photogrammetry to learn this. This should just be available for anyone to pick up, learn, and experiment for themselves. And so, we will continue sharing. This is only 3 captures of the same building.
Yeah.
I think by the 10th capture, we will have it perfectly modeled.
We will. We will. Don't come looking for my mill, though. That mill's mine.
That's it.
If I find operators near my mill, I will be cross. It's not mine. I'm not going to tell you where it is. So I think that's the reason we've done it. We want to share what's achievable. And as Varun's just said, it's only 3 captures. We'll keep capturing until we're thoroughly happy with it. And then of course we'll share all that data.
Absolutely, yeah. And if you have any thoughts or comments on after watching this, if you think how these captures could be made better, or anything you've seen in the past, or any learning you've had in terms of improving the photogrammetry capture, do let us know in the comments. I
Yeah,
think
please
it was
do.
great.
You know, drop us a comment.
Mhm.
As you know, as per usual, you can drop us a like, you can subscribe, you can ring the bell,
Wow.
which is something new. You
Mm.
know, like people on YouTube have been doing it for years, but I just wanted to say it. Ring the bell. And that will, I think that gives you the option. It tells you when a new video is released.
Yeah.
Is that right?
That,
that
I think I think that's what it does. Yes.
Okay.
I think I've rung
Good.
the bell a
I
couple
think
of
I got
times.
that right. You know, and if you want to get hold of us, we're available on team@hammermissions.com. Again, you know, we've now created a separate playlist on our YouTube channel, which has all of our podcasts on it.
Mhm.
But we're also available as an audio podcast on all your podcast directories and stuff.
Brilliant. There we go. You perfected that.
Kind of have. It just got rolls off the tongue now.
It does.
And
Yeah.
now I can say ring the bell every time as well. Yeah.
Ring the bell.
Ring the bell. Yeah. Cool.
Brilliant.
Nice one.
All right. Yeah.
All right, Varun. Well, that was, as an experiment for our first visual podcast.
Yeah.
Where we doing something else visually, not just my face and your face and maybe a guest's face on the screen. I think that went quite well.
Yeah, absolutely. Yeah. Looking forward to seeing what people say. Yeah.
Indeedy.
Brilliant.
Cheers, everyone. Thanks, Varun.
Thanks
and,
all. Thanks, Alex.
Catch up with everyone later.
Catch you later.
All the best.
Cheers. Bye.
Bye.